So in this question we're told the flight of an aircraft used to simulate weightlessness can be modeled by the quadratic equation negative 10 t squared plus 300t plus 9,750, where h is the altitude of the aircraft in meters and t is the time in seconds after weightlessness begins. And they ask us a series of questions here. At what altitude does weightlessness begin? So first off, what are they asking us in this question? They're saying at what altitude? So altitude is h, so we want to find a value for h. When do we want to find this value of h? When weightlessness begins. So t is the time in seconds after weightlessness begins. So weightlessness begins at t equals 0. We've done a question similar to this before. So we just want to sub in t equals 0 to our equation and evaluate to find our value for h. So h is going to be negative 10 t squared plus 300 t plus 9750, and we're subbing in t is equal to 0. Well, this is pretty easy because this term is going to be 0 because we're multiplying by 0. 300 times 0 is going to be 0 as well. So we're just going to be left with h equals 9,750 meters. That's when weightlessness begins. Let's look at part B here. Find the maximum altitude reached by the aircraft. Well, at this point, we might want to make a little diagram of what we're talking about here in terms of this parabola. So I'm going to sketch a little graph here. We've got t on our horizontal axis. We've got h, or the height, on the vertical axis. We know that weightlessness begins here at 9750. So the height of our aircraft is going to go up, and then it's going to go back down again because this is a parabola that opens down because our a value is negative 10, and that's negative. So parabola opens down. So maximum altitude reached by the aircraft. Okay, if they're asking for maximum, we know that we need to find the vertex. And if they're asking for altitude, altitude of course is a value for h. Okay, so we need the value of h at that vertex. So how do we find our vertex here? Well, we know a bunch of ways of finding our vertex. We can, I'll just list them all over here. We can complete the square. We can factor to find the x-intercepts. And then we know that our vertex is halfway in between. And if we can't factor, we could use the quadratic formula to find the x-intercepts. Okay, so this one I think we'll do by the first method of completing the square. So we'll start with our original equation here, t squared plus 300 t plus 9750. In completing the square, we know we have to zoom in on these first two terms here. We've got that negative 10 out front, so we have to factor the negative 10 from those first two terms. We'll have negative 10 t squared minus 30 t plus 9750. Now we have to take that t squared minus 30 and we want to turn it into a perfect square trinomial. So we are going to take our 30 divided by 2 to get 15, square it, and that's going to be the number that we have to add on or subtract off inside our brackets. So that's 225. Plus 9750. Then we know that these three terms here are going to factor to be our perfect square trinomial. Negative 10 t, not plus, but minus 15 squared. And as we do this, we're going to multiply the negative 10 by the 225 to get positive 2,250. And this is going to get added to that 9750. to give us a final vertex form of negative 10 t minus 15 squared plus, if we add these two things up, we are going to get 12,000. Okay, so our vertex from our vertex form here is going to be 15, 12,000. We could add that onto our little diagram over here. The 15 is going to be the t value where this occurs. The 12,000 is going to be the h value, which is our maximum. So this is t and this is h. So what were they asking us for in the question? Find the maximum altitude. We can say that the max altitude is 12,000 meters. That value for h. H and T. All right, let's look at part C here. How long does weightlessness last if it begins and ends at the same altitude? Sometimes they ask us questions like this that we can actually answer without doing a lot of math, just by sort of looking at the graph that we've constructed here. So we know that weightlessness begins at this point right here. It ends at the same altitude. So it's going to end over here, okay, where our parabola comes back to that altitude of 9,750 again. What they're asking for is how long does weightlessness last? So they're asking for what's the time interval between these 2 points here. Well, looking at our graph, we know that from when weightlessness starts to that axis of symmetry is 15 seconds. Because our parabola is symmetric, the distance from the axis of symmetry to that point where weightlessness ends, or the symmetric point, also has to be 15 seconds as well. So that means the total distance in terms of time between those 2 points is going to be 15 plus 15. It's going to be 30 seconds. Okay? So we could do this question just by sketching a little graph of our parabola and putting the given information on it. Let's look at our last part here. How long is the aircraft above an altitude of 11,000 meters? Okay, let's try to visualize this on the graph as well. 11,000 meters is a height. Okay, and sorry, they're giving us a height. H equals 11,000 meters, and they're asking us for how long. So they're asking us to find an interval of time. Our 11,000 meters is going to be, let's say, right about here on our graph. So our plane reaches that 11,000 meters at that point right there. It goes up past it, and then it comes back and it's at 11,000 meters again here on the other side. So just like in question C, they're asking us for this time interval from here to here. Okay? So what we want to do is we want to find the coordinates of those two green points that I've just put on the graph. How are we going to do that? Well, let's see. They're giving us a value for h, which is 11,000. Let's sub that into our equation for h. So our equation is h equals negative 10t squared plus 300t plus 9750. And in for h, I'm going to sub 11,000. We want to solve this thing for t. So solve for t. The first thing we have to do, though, is quadratic equations. We can only solve them if we have 0 on one side and everything else on the other side. So we're going to subtract 11,000 from both sides to get our equation in the proper form. This doesn't change any of these first terms. It's just going to change this constant term, and it's going to make it minus 1250. All right, now how do we solve this equation? We know a couple of ways of solving quadratic equations. We can factor, or we can use the quadratic formula. If you're not sure whether or not it's going to factor, I would recommend using the quadratic formula. This one here is factorable, so I'm going to go ahead and factor it to solve it, but you would get the same answers if you used the quadratic formula. So I am going to start by first common factoring. I'm going to factor out a negative 10 from each one of these terms. Notice factoring out a negative is going to change the sign of each one of those terms, and I've just divided each one of them by 10. Now I can factor this trinomial that I have inside the brackets here. This is a simple trinomial. I know it's going to be a t here and a t here. Breaking this down a little bit, I know I'm looking for two numbers that multiply to give me 125, positive 125, and they add to give me negative 30. Those two numbers are 5 and 25, and both of them have to be negative. Negative times negative will give me that positive. So inside the brackets, I have a negative 5 and a negative 25. What are my two solutions? My solutions are the numbers that go in there for t that are going to make those brackets equal to 0. So I'm going to have from the first bracket t equals 5, and from the second one t equals 25. So does this make sense with the graph that we constructed up above? Remember, we're looking for these 2 points here and here, right? 5 and 25. That certainly looks reasonable. So that entire distance, where it's above 11,000 meters, is going to be the time from t equals 5 to t equals 25. So that total time is going to be 25 minus 5, or 20 seconds. So therefore, plane is above, what was it, 11,000 meters for 20 seconds.